Venus will dominate evening skies this August, while Mercury and Jupiter form a tight dawn pairing. NASA has assigned astronaut Deniz Burnham to her first space station mission. She will fly to the International Space Station next spring aboard the Roscosmos Soyuz MS-30 spacecraft. Burnham, a former NASA intern, will make her first trip to orbit on the mission. The assignment adds another crew member to the steady rotation of international partners visiting the station. NASA released the news alongside details on her background and training path. Watch for further crew announcements as the launch window approaches. From one astronaut's path to orbit, we turn to the maintenance work that keeps the station running. Flight directors outline 3 spacewalks scheduled outside the International Space Station during August. The outings will focus on maintenance and science hardware tasks. Live coverage of the preview briefing is available through NASA channels. Crews are preparing equipment and timelines ahead of the first excursion. The schedule keeps station operations on track through the summer. While crews handle station upkeep, the night sky offers its own seasonal maintenance in the form of shifting planets. Venus will stand out as the dominant evening planet through the month. Mercury and Jupiter will appear close together in the pre-dawn sky. Observers can track these positions with basic equipment or the naked eye under clear conditions. The changing geometry offers repeated viewing opportunities across different latitudes. Charts map the planet's paths night by night. Mercury's current brightening phase gives us a closer look at the innermost planet itself. Mercury has reached magnitude 0.5 and continues to brighten ahead of its greatest western elongation. The planet sits low in the early morning sky and should remain visible for several more days. Observers are encouraged to look shortly before sunrise. The current elongation provides one of the better chances to spot the innermost planet this year. Daily updates track its changing position and brightness. Mercury's weak magnetic field adds another layer to why the planet behaves the way it does. Mercury's weak magnetic field periodically captures and funnels solar wind particles toward the surface. The field was first detected in 1974 and continues to surprise researchers given the planet's small size. Data show the field creates temporary trapping regions rather than a steady shield. These interactions differ from Earth's more robust magnetosphere. Future orbiter measurements will map the variability in greater detail. From our own solar system's extremes, we move to a nearby galaxy that serves as a natural laboratory for star formation. The James Webb Space Telescope is examining binary stars inside the Small Magellanic Cloud. The galaxy's lower metallicity offers a natural laboratory for testing how metal content affects stellar pairs. Early data already showed differences in mass transfer and evolution compared with Milky Way systems. The observations target young binaries still embedded in their birth clouds. Results will help refine models of star formation across varying galactic environments. If the Sun formed inside a galaxy like the Small Magellanic Cloud, it would have started with only 1/5 the iron and other heavy elements we measure today. That scarcity changes everything about how a star sheds its outer layers and how 2 stars in a pair exchange mass. In metal-poor gas, stellar winds are weaker, so stars retain more mass until they expand and fill their Roche lobes. A typical close binary might then transfer material at rates 10 times higher than equivalent Milky Way pairs, driving rapid spin-up or even envelope ejection on timescales of just a few 100,000 years. We can watch the outcome in ultraviolet and infrared light, yet we still cannot predict whether the same low metal conditions produce more neutron star mergers or more stripped envelope supernovae. The unanswered piece is whether these altered pathways also change the final compact object mass distribution in ways that affect gravitational wave signals we detect from across the universe. Stars and stellar remnants already account for the vast majority of a galaxy's baryonic mass, so shifts in binary outcomes could reshape how entire galaxies evolve over cosmic time. While JWST peers at distant binaries, closer to home, experts are warning about traffic in cislunar space. Proposed lunar missions from multiple agencies are increasing traffic between Earth and the Moon. Experts warn that debris in cislunar space could threaten both robotic and crewed spacecraft. Current tracking focuses mainly on low Earth orbit, leaving higher regions less monitored. The article outlines gaps in coordination and data sharing. International discussions on traffic rules are described as increasingly urgent. Orbital congestion concerns extend beyond the Moon to proposed data center constellations. Companies planning large constellations of data center satellites face new questions about collision avoidance and spectrum use. Experts recommend developing safety protocols before the first systems reach orbit. The article notes gaps in current licensing frameworks for non-traditional payloads. Early coordination could reduce later conflicts with existing operators. Industry and regulatory groups are beginning preliminary discussions. From future infrastructure in orbit, we return to striking images of our own planet captured this week. A radar image from the Copernicus Sentinel-1 mission shows New Orleans and the Mississippi River Delta in detail. The instrument penetrates cloud cover to map the river's sediment patterns and coastal features. The Delta ranks among North America's largest river systems. Repeated passes allow scientists to monitor changes in wetlands and navigation channels. The image adds to the mission's archive of dynamic coastal regions. Earth imagery leads naturally to beautiful deep sky views released this week. The daily astronomy picture features the globular cluster NGC 4372 alongside the dark Doodad Nebula. The cluster lies in the southern constellation Musca. The dark nebula appears as a striking lane of obscuring dust against the background stars. The image combines data that reveals both the dense star field and the foreground dust structure. Such pairings illustrate how dust and star clusters interact along the Milky Way plane. From nearby star clusters, we look at processes that shut down star formation in the universe's youngest galaxies. JWST observations reveal processes that appear to shut down star formation in some of the universe's youngest galaxies. Compact objects lose gas reservoirs faster than models predicted. The findings come from infrared imaging that penetrates dust in distant systems. Astronomers compare the results against simulations to identify which feedback mechanisms dominate. Follow-up spectra will test whether outflows or other processes are responsible. From galaxy-scale quenching, we turn to a single black hole that refused to settle down quickly. New observations captured a black hole outburst followed by extended changes in surrounding material. The event was led by Warwick postdoctoral fellow Dr. Noel Castro-Segura. Data indicate the system retained heated gas and altered accretion patterns long after the initial flare. The findings challenge simple models of rapid return to quiescence. Additional monitoring will track how the disk settles over coming months. From cosmic extremes to hands-on student research closer to home, participants in NASA's Student Airborne Research Program released ozone sondes from the Texas Gulf Coast. The balloons carried instruments to measure ozone profiles through the lower atmosphere. Windy conditions tested the team's handling skills during launch. The flights formed part of the program's final summer session that ended July 27. Data will contribute to regional air quality studies. Student fieldwork on Earth contrasts with satellite views of recent wildfires. Satellite views document extensive fires across Spain and France during recent heat waves. Prolonged drought left vegetation highly flammable. Imagery shows burn scars and smoke plumes moving with prevailing winds. The observations help map fire progression and assess damage to forested areas. Similar data support ongoing efforts to understand drought-fire linkages. From Earth monitoring, we close with one more skywatching note. Vega shines as the brightest star in the summer triangle, visible overhead in July evenings across the northern hemisphere. Astronomers have studied the star extensively because of its brightness and proximity. It ranks among the most observed objects in the summer sky. Historical records show people have tracked Vega for thousands of years. The star continues to serve as a reference point for calibration and observation programs. Keep an eye on further details about the 3 scheduled August spacewalks as crews finalize timelines. That's Fascinating Frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at NARA Network. Links in the show notes. Quick tip from the network, try Environmental Intelligence Next, the environment and climate policy brief for Canada. Every NARA Network show is free at naranetwork.com. Following the long arcs, story trackers on naranetwork.com follow major programs across episodes: Tesla, SpaceX, AI, space science, and more. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly through